right, lesson 1.4, part 2 here. First, it talks about converting absolute value function to piecewise functions, and we're just going to skip this for right now. So that means that on your assignment, you don't have to do numbers 13 and 14, okay? So we're just going to skip this for now. We'll hit it later if time allows us to. So let's go ahead and let's look at some applications from real life. All right, so in the land of Leibniz, a person filing taxes as single pay taxes based on the following table. All right, so they gave us a table here, and you can see if your taxable income is at least this amount, but not more than this, you're going to pay this as the tax rate of any amount over something. Okay, so it says write a piecewise function t of x, giving the tax owed by a person whose taxable income x is x when x is less than $125,000. So we're just going to make this into a piecewise function. All right, so t of x equals. Now we've got three different rows, so we're going to have three different equations, okay? So the first equation, they're going to pay 15% of their income. Well, how much is their income? We don't know. That's our x. So they're going to pay 15% of their income. And then when are they going to pay that? Well, when they make between $0 and $30,000. Then if their income's between $30,000 and $65,000, they're going to pay the $4,500 plus 20% of their income over $30,000, okay? And they do that when their income is $30,000 up to, but not including, the $65,000. I'm sorry, I'm out of room. And then the last one there says it's going to be $11,500 plus 24% of their income over $65,000. So we're going to take the income and subtract out the $65,000. And they use this equation when their income is $65,000, equal to $65,000 and up to $125,000. I forgot my inequality symbol there. Sorry. That's less than $125,000. Let me do that. All right, so there's our equations. B says to evaluate the function to find the tax owed by a single person whose taxable income is $68,750. All right, so $68,750 fits in that last equation because it's between $65,000 and $125,000. So our tax on the $68,750 is equal to $11,500 plus 24% of that $68,750 minus the $65,000. Okay, so it gives me $11,500 plus 0.24 times, and so $68,750 minus $65,000 is $3,750. So we got $11,500 plus, when I multiply them, we get $900. And when we add them, we get $12,400. And make sure you label it. It's money, okay? Has to be labeled. All right, moving on to example 8. It says in August, Orlando Utilities Commission supplied electricity to residents for a monthly customer charge of $8 plus 10.143 cents per kilowatt hour for the first 1,000 kilowatt hours used in the month, and 12.143 per kilowatt hour for all electricity over 1,000 kilowatt hours in the first month. What is the charge for using 920 kilowatt hours in a month? All right, so they're being charged for that first 1,000, 10.143 cents. So we're going to pay that $8 plus 10.143 cents, which I need to change that to a decimal. So that would be what? 0.10143 of a dollar, since we got the $8 already there, times the kilowatts, so 920 kilowatts. So I'm just going to put a C for charge here. So I get $8 plus 0.10143 times 920. I got 93.3156. Did I do that right? 0.10143 times 920. I did. Plus 8. So I got 101.3. It says 156. Remember, it's money, so we round it to 2 decimal places. So $101.32. Then it says, what is the charge for 1,500 kilowatts? Well, the charge for 1,500 kilowatts is going to be $8 plus, we're going to do the 0.10143 for the first 1,000 kilowatts, plus, then it says it goes up to 12.143 cents per kilowatt hour for anything over 1,000. So that's going to be 0.12143 times, how much over 1,000 did they have? Well, they had 500 over it because they had 1,500 total. All right, and so we're just going to work this out. So $8 plus 101.43 plus 60.715. We add all that together. And I got 170.145. Remember, we're talking about money. So it's $170.15. And then C says, if C is a monthly charge for X kilowatt hours, write a piecewise defined function for C in terms of X. This would have made our life a lot easier if they had made us do this to begin with. But, so we've got two scenarios. We got if it's below 1,000, and then we got if it's above 1,000, okay? So we're going to have two equations here. So we know that it's going to be $8 plus the 0.10143 x when our x is less than or equal to 1,000. But then it said it's 8 plus, now that we're going to do that 0.10143 for the first 1,000, plus, then we changed it to 0.12143 for anything over 1,000. So that would be x minus 1,000 here. And we would use that for anything greater than 1,000. And we can actually simplify that equation up. So I'm going to do that here, clean it up just a little bit. So my first one was okay. I'm going to come back and write its domain after I do the second one. So then we had what, 8 plus, let's do a little work here. So 8 plus 101.43, and then we got plus 0.12143x. I'm going to distribute this here, okay? Minus 0.12143 times 1,000. So minus 121.43. And so when I go and put all this together, I've got 1.12143x, and I'm going to combine these three like terms. So 8 plus 101.43 minus 121.43. And so I got minus 12. And so remember, the first one was anything less than or equal to 1,000, and the second one is over 1,000. And so this is our piecewise function. All right, so that is the end of 1.4. So remember, we skipped over that one part, so I said you could omit 13 and 14 for right now. And we'll start 1.5 in the next video.